Our next speaker is Tracey Jaquith. Tracey is an operations leader at the Internet Archive. Now, I cannot tell you how many times I personally have been to archive.org to look at a website and see what it looked like at a certain time. I'll just say it's been a lot. So when I found out that archive.org was using GitLab, I was very excited. And hearing Tracey's story, she has a lot of great technical details to share about using Nomad as a deploy target and some plug and play GitLab CI YAML for you to check out yourself. So Tracey will share all the links and y'all can check it out and catch up in the chat.
Welcome to GitLab Commit 2020. Thanks for joining my talk. It's called Simple CI/CD with GitLab and Nomad, and my name is Tracey Jaquith. For a few of these intro slides, there'll be a little bit.ly link at the bottom in case you want to follow along. And it's just a web page, so you can open, and it'll just open up with slides, and you can navigate with the arrow keys. Okay, so a little more about me. I work at the Internet Archive. I've been there since the start, so it's about 24 years now. My title is TV Architect, although I also work heavily in video and audio, as well as DevOps, and do a lot of JavaScript now. And the repo that we're going to talk about and use here and refer to from time to time is all on GitLab, so gitlab.com/internetarchive and /nomad, it's linked below. If you don't know me, which you probably don't, this is kind of my normal MO. Like, whether you like it or not, our conversation will probably start talking about containers. If you're friends or colleagues, it's probably great professionally, not so great for my friends, but I love containers. But we don't talk about this kind of containers. That never happens. Okay, so why are we looking at Nomad, which is part of the Hashi Stack, versus Kubernetes, which is very nicely integrated in with GitLab? So I thought I would discuss some of the applications that you install from the Kubernetes side, which are the GitLab side, which are super easy. So once you've got a Kubernetes cluster up and tied in, you just usually press one button and you get your ingress, one button and you get your cert manager for HTTPS, and one button so you get your runner for running your CI/CD. For each of them, for all the repos that deploy this way, you'll get what they call a review app. So you'll get a web app that's unique for every single branch and for every single repo. Now on the Hashi Stack side, instead of an ingress or the Kubernetes ingress or Nginx, they're using a load balancer called Fabio, and that's the one that they most typically recommend. To keep things simple, I'm actually doing domain-based Let's Encrypt scripts that I pass into Fabio, and I'm just going to manually redo those every 90 days just to keep things simple. And there's some scripts to help you with that if you're interested. I install a GitLab runner just like with the other stack, the Kubernetes stack, as on one of the nodes in the Nomad cluster, so I can do CI/CD. And in the end, each of them are going to make review apps just the same URLs, same kind of names and addressing. So who is this talk for, most likely? It doesn't have to be all of these, but probably some of these, where you're probably already familiar with GitLab CI/CD, or you've used it or are interested in it. You might do some on-premise Kubernetes clusters, or you might maintain your own clusters, or you might have had some experience or poking around with that. If you have, you've probably noticed that Kubernetes is great, but it's kind of a big thing, and it takes a fair amount to kind of get your head around and to maintain. So you might be wondering, is there something smaller? Like, what else would there be out there? And that's what this talk is going to be about. And you might feel like maybe you could simplify your deployments and not have to go through Helm and all that kind of stuff. So the approach and goal that I was taking from this after a couple years with GitLab Auto DevOps was, I love it, and our devs love it, so could we just make the swap out with Kubernetes with Nomad be super easy and as easy as possible? And it turns out we can just use GitLab's great build phase in their chart, their default chart, and we can use their testing phases and some of the other phases if we want, and all we have to do is customize the deploy phase, so it deploys to the other cluster. You might also be wondering, why Nomad, Tracey? I haven't really heard much about it. Well, I work at the Internet Archive. I'm their main DevOps person, and we had a bad month in, I think it was March or April. I think it was April, where we had some issues where Kubernetes v118, which had come out fairly recently, I couldn't get it to install with our networking. I mean, it would install, but I couldn't get the cert manager integration to work, which meant we didn't have HTTPS. In addition, we were running kubeadm with a Kubernetes cluster of v114, which turns out it had a 1-year cert expiry, which just expired without warning, without any kind of email or anything. So I was completely cut off from the cluster, as was all of my devs. And that was a week of panic and just flailing and hitting keys. Eventually got it pretty close to back, but in the end it was burning the cluster and remaking it. I've also been seeing a fair amount of persistent volume using Rook and Ceph corruptions. It could be me in the way that I'm installing it, but I've just been having a bunch of problems with it. So we thought it might make more sense to, since this is mostly databases and Redis and things like that, kind of important data, and Sentry, we would instead use local storage, so we wouldn't have to worry about bit soup when you come up with disks that have fragged files and things in them. Also, GitLab at the time, which has now been fixed in v13, had some workarounds if you were using newer Kubernetes stacks, and it worked, but it was kind of like I had to put it in for every single repo, and it was getting to be a little bit much, so I went looking. And as you know, no job is ever worth your sanity. And software developers and DevOps, maybe we need to remember that. I like the little side eye here. Okay, so why Nomad specifically? So archive.org, it seems our ops team has a little bit of a preference for it over Kubernetes. They already knew Consul, which is one of the big pieces in this little stack. They're very attracted to some of these deploy script alternatives. So you can deploy scripts, just not Docker containers only, where you do the exec driver or the raw exec driver. They have different trade-offs, but you could do like crons, you could do scripts that run maintenance stuff. If you've ever tried making a Kubernetes custom resource definition, or like tried stumbling down that path as I did, it's kind of hard and seems like a lot. So the idea that you can just run little scripts seems very attractive. And then finally, if you're a small place, or maybe you've got like a small subset, or you're a small subset in a larger group, smaller tools are often a little bit of a better fit, it seems like. So what's the Hashi Stack? So the Hashi Stack, in a nutshell, is 3 main tools at a high level. So Nomad, which will take care of your deployments, Consul, which will take care of your networking, and Vault, which will take care of your secrets. And a little more depth to what I just said. So for Nomad, you'll be doing deployments, you'll be doing container rollouts, you'll be doing Canary. If you're doing Canary, you'll be doing rollbacks, all that kind of stuff. You'll be doing restarts and scheduling, so it'll figure out where to pack things. It can do, Nomad can schedule 1 million containers in 5 minutes, 1 million Redis apparently. Oh, I should stop moving my hands. And then finally, Vault will just do your secrets like normal, so kind of like your Kubernetes secrets. Oh, sorry, I skipped Consul. Consul will do service discovery and communication, as well as configuration. So once you do a deployment of a new repo or of a new branch or something like that, your load balancer will instantly have it discovered, and we will be able to route traffic right to it. So that's nice and simple. So what does your stack look like now? Well, probably it looks like most people's web apps, right? It's got, you've got a browser that's probably going to talk HTTPS. It should be talking HTTPS, people. It's 2020. To your web apps, it's probably going through some sort of a load balancer, and ultimately it's going to be talking to some sort of web app somewhere, which will probably be talking to a database or a Redis or a Sentry or something like that. Not a Sentry, some other, Cassandra or something like that. So how does the Hashi Stack slip into this? Well, it's pretty straightforward. So you'd have your GitLab CI/CD on the right side of the slide here, doing a normal deploy, push out, or a normal commit, push, and then full CI/CD pipeline. Or maybe you're doing some administrative kind of work or something. You're probably going to be talking to the Nomad daemon. The Nomad daemon, in turn, can talk back and forth to the Vault daemon, get secrets, and get some other information out of there if you need it there. And then it will talk back and forth to your console daemon to make sure you've got networking between your jobs and your tasks and things like that. The console daemon can also talk to your load balancer to make sure the service discovery is all set up. And ultimately, once everything's set up and your job is templatized and expanded, your Nomad daemon will then talk to your Docker daemon, depending on which node or nodes that's running on, which will then fire off your task groups. Your task group is basically like your little like web app. It could be like a node app, or it could be a PHP little stack, and then you could have a some sort of a database or a backing store. And this is very much like a pod. So this is a task group where that's one task and that's another task, and I think of this as a task group. And then finally, I have a little arrow going from here to here, Docker daemon to the Fabio load balancer, because Fabio actually happens to just be another deployment. So it's another Docker container that is deployed through this whole system. So that just makes things nice and easy to set up and run. So again, our approaches and goals here are make Nomad an easy swap. We want to use the build phase because it's really sweet. It works great. It does all the things you need to do. It will make your containers. It'll use caching. It'll push right to the registry, whether it's on-prem as a GitLab instance or you're using gitlab.com. So super easy and simple. So just stick with that. And then the custom deploy phase, what we need is a project HCL file, which is kind of like a merge between YAML and JSON. And we're going to set it up dynamically, which was sort of an idea I had, instead of making a project HCL per repo, because that would be a lot if you have a lot of repos like we do, and it just gets to be a lot of boilerplate. So we're going to use something called Levant, which is a simple ability to swap out variables and do some basic like if-else kind of logic. And we're going to merge the normal GitLab CI/CD variables with any other environment variables and anything from the vault that came in as secrets as variables. And then we can merge all of those together with this project HCL template, which we're going to go over. And that just makes a project HCL for your deployment, and then it just goes ahead and deploys. So the goal is every time you deploy and every time you do a git commit and a git push, just update your review app. All right, so that might be a lot. You might be like, I'm really bored, Tracy. Like, can I get out of this talk? Yes, you actually could get out of this talk if you really wanted to right now. So 2 lines, if you really want to, just the bare minimums, you can include this and you're pretty much going to be good to go. We'll go over this so it's not just magic soup. But this is talking about that same Internet Archive GitLab deploy, so you can see all the code right there. We're pretty public with a lot of our code. And it's going to load this custom CI/CD YAML file. So you just add that to the top level of your repo in a new GitLab CI/CD YAML file, those 2 lines, and you should be good to go. The only other thing you need is a way to talk to your Nomad cluster. So we have it set up so there's a Nomad adder and a Nomad token. If you put those in each GitLab repository's settings, you could do a group repository. You could do a group GitLab setting as well. That's really convenient. We're doing that. You go to the settings, and then you find the CI/CD, and then you set up the variables. So you set your Nomad adder to whatever your Nomad cluster name is, and then usually 4646. And then the way that you get access to it is you just get this little token, so it's real simple. It's not like the kube config, it's simpler than that. And you just punch that in as another variable, and you're good to go. So you might be asking, what's in that magic CI GitLab CI YAML file? Well, here it is. So I'll just scroll down to the bottom. I guess I didn't do the include. I don't have to because we're doing the GitLab CI/CD standard thing. So I'm just sticking with build, test, deploy, and cleanup to keep it pretty simple. Standard build, standard test if you're using it, customize, deploy, and lightly customize cleanup. Cleanup is when maybe you merge a branch, you delete a branch, and then it just removes resources from your clusters. Same as with Kubernetes. So that's setting up the stock build from GitLab right there. As you can see, there's some more documentation there if you want to see that. Then I'm going to set up a few different variables. We can get into more of that later. That's just to make things a little bit easier and cleaner in the templates. And then for the deploy, I'm actually going and grabbing the generic project Nomad template. So it's highly variabilized. if you will. And then I do this cute little trick here where I pull out all the CI/CD variables from your normal build shell, and I stuff it into a JSON file, so that just makes it really easy for Levant to take over. Levant takes over from that little JSON file, takes your generic project template and makes a specific project HTML just for you, removes the file, and then it goes and does what you would normally do with Nomad, which is Nomad validate, so it makes sure that the validation of your project is going to work. It plans it, figures out if it's going to land somewhere, and then it goes ahead and runs and deploys it. This is just kind of pretty typical to figure out which cases you're doing deployments and which cases you're not. And then this is like just lightly modified to make sure that when you get down to removing or deleting a branch, we just do Nomad stop, and that just gets rid of your resources too. Pretty straightforward. So what does a Nomad project look like in general? Well, this is the high level sort of brush contours, if you will, of it. So there's going to be a little job stanza, and this kind of is that YAML JSON kind of merge I was talking about. There's going to be a group. So if you just have a single container, it's going to be a single task in a single group. If you had like a second database, you'd have a second task in your group. It's usually pretty common to just do something, 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 the same label. And then I'm just showing this is like the simplest way to get to your CI/CD variables from your Docker image. We're going to have to do a little bit more than that from GitLab, but that's the rough brush strokes. So let's look at what's the minimal thing. Let's say you didn't want to use my repo or anything like it. What's the minimal you could get away with? Well, it takes a little bit of time to figure out, but it's not too hard. So if we just stuck with standard classic CI/CD variables right from GitLab, we can make a nice looking job name. I'm going to refer to it as a slug later, but it gives your project, which is your group and path slug. So it'd be like Internet Archive / Nomad or dash Nomad in our case, and then whatever your branch name is here. So that just sort of templatizes out pretty nicely. Again, we're using the same image down here, starting with the registry and then using similar slugs kind of stuff, and then whatever commit. The Docker login, it's already got pretty nicely set up for you for using the registry in GitLab.com, or if you're hosting yourself, your own GitLab instance, so we just go ahead and use that. And then we can just go ahead and deploy it. And I'm just doing a really pretty standard kind of setup here, so keep it nice and simple. And then this tag thing is just for Fabio, the load balancer, to figure out service discovery and set up a name. And we're going to use HTTP, and we're going to check it every 10 seconds. Okay, to keep things a little simpler, because that was a lot of variables, I've set up something called nomad __ slug, and that's just to set it off from nomad _ variable. So anytime you see nomad __, that's just specific to this talk and this repo and how I set up things. So I'm set up with your GitLab group, your project, and your branch. I omit the branch if it's master, just to make a shorter slug, and it's kind of redundant, or main. I guess main is probably a better name these days. So here's a couple examples. If we had the group IA and Petabox, which you do at archive.org as your repo, we might have a branch called web dev fix things. So we'll come down here and we'll see that as the slug, and that's going to get used pretty much everywhere. So keep it real obvious as a one-to-one mapping where things come from. And then here, because I was using a master or main branch, I just omitted it, so services time machine. If you want to see like kind of how a cluster looks, like kubectl get all or something like that, this is kind of similar. So this shows you all the different jobs. So here's your Fabio load balancer. Here's a couple groups, and then here's a couple different projects, and then here's even a couple. This would be 3 branches and deployments within one group. And so they're all running happy. That's lucky for us. Great for us. So if you want to see the full templatized project Nomad, it's linked in that last slide, and it's linked in the repo, so it's easy to find. This is what it looks like. So we're going to use this Nomad slug, which we define earlier on in the GitLab CI/CD YAML. We're going to set it up for the group and the task name, just to keep it simple. Again, same Docker image. We've got some repos using WebSockets with additional ports we need to get out, not just the HTTPS port. So if you have additional ports, I just made that really easy for you to add that in. This is the Levant style variables, all of these guys, the hard bracket dot, and then hard bracket, some control language. So it's pretty easy to understand. I actually upgraded to it later, and I was really delighted by it. If you're having problems with Docker login, I'll get to that later. There's a little stanza here that can use an alternate method to log in. It's pretty straightforward, a little more fleshed out. You can use a different, if you didn't want to use HTTP, you could use TCP. You can even use scripts for checking your health checks. But the simplest one is just talk to port 5000 in your web app at the slash repo. If you're using additional ports, we can check those as well. So there's some stuff like that. If you're using Vault for secrets, there's some basic helper information here, but it's going to go ahead and talk to a little bit lower, or it will have already actually talked to the Vault, and it can get to your secrets this way. And this is how you can set up a key value store secret. So if you wanted to set up some key and some value, let's see how we're doing the time. Ooh, we're getting a little late. I have some NFS mounting if you're interested in that kind of stuff. We've got a Postgres and a MySQL and so on and so forth. So some other factors we'll be starting to wrap up here. All of this can be run without a container network interface, so you don't have to run Flannel, Calico, or Weave if you don't want to. You can if you like. We found Docker login is occasionally flaky. It might be if you're trying to redeploy something like a week or two later or something like that. I just found that sometimes it doesn't work quite as well. So just had a little suggested thing. Go ahead and make a deploy token. Give it the read registry. You can read about this more later. It's pretty easy to set up. And then if you just set up a CI/CD variable with your username and password, that'll just automatically go right into your template, into your deployment. And I haven't had any problems with that. I just set this up as group logins. For monitoring and usage, I'll show those slides in a few seconds. It's really easy to talk to your Nomad cluster. Use the exact same 4646 URL that we used before, and then the repo will deny you until you enter your token, and then you're in. So here's what it looks like. We can sort on data centers and all sorts of different stuff. So we can look at the Fabio load balancer and different running jobs. So let's go ahead and look at the Fabio one, and we can see their concept of replicas is called allocation. So there's two of them running. So I've got two running on two different nodes in the cluster, and that just makes it nice and easy. If one of your load balancers goes down, your traffic can cut over to the other. And there's also this exec here, so you can SSH in right from the GUI. The other thing that I really like is you can see the entire job definition here. So sort of what we expanded out the generic template to, also what the system added in. You can go ahead and edit it right here, and it'll redeploy, so it makes it really easy to try out stuff. Super, super nice and simple. I've got a little aliases thing, which is linked right in the repo. That makes it super easy, and I'll kind of gloss over these a little quickly, but there's one called nom-ssh, which uses your current working directory. Like let's say you've checked out a branch and you're sitting in it in a terminal. You just type nom-ssh, and within a second or two, you're SSH into the container because it looks at your Git repo to figure out the information, and then look up the allocation and just SSH you in. Similar, nom app will just open the URL right to your web app. So whatever your URL is, you don't have to look it up. Nom-cp, this is great stuff. We use it in Kubernetes as well. This will hot copy a file right from your laptop. So if you're using like VS Code, you can just hook in this little deployment, and every time you hit save, it will automatically copy right to your container. So you can just hot reload it right like that. You don't have to deal with a 10-minute or 20-minute deployment if you have a monorepo. Super game-changing. Here's a bunch of things that you can customize. These are these nom__ variables, so you can add more ports. You can do NFS if you want, or something like that, different host names, and so on and so forth. This is a more complicated slide. This is talking about a multi-cluster setup. So you've got two virtual machines, and you've got your CI/CD deployments that will talk to your Nomad daemons, which will talk to your Docker daemons. In this case, we've got a web app running 3 copies of 2 virtual machines, and your traffic comes in through your load balancer, which is running on virtual machine 1, routes your traffic over to it depending, and so on and so forth. So pretty straightforward. Okay, so if you're using big monoliths and monorepos, you might want to avoid Docker and Docker in your build. This repo shows you how to do that. We'll use docker.socket. Especially if you're on premise, I highly recommend it, because every time your Docker build starts up, it's like waking up on a blank canvas. There's no ability to cache, so you've got to do your full Docker image pull downs. If you're using big 4 to 10 gig images, that can get very weighty, and that'll save you a lot of time if you don't use it. If you're using Git partial clones, you want to take over using Git, that will save you a lot of space because you only need versions of files that pertain to the given branch or commit. So if you have binaries checked in or something like that, or tons and tons of versions, we have 20 years of history checked in, that'll save you a ton of space in your image if you're using, if you have a Git branch or a Git checkout inside your Docker image that you run. This is how, if you wanted to run your own Git management, strongly recommend do a Git detach, and that will detach your head and make sure you're not getting tangled up with anything like checked out or something like that. Then you can fetch from origin whatever your branch name or your commit is. That's what this checkout variable is, and it'll just Git fetch it. And then you just go ahead and check it out locally, and that changes your pointer to be the exact same pointer as your origin. It happens super fast, within seconds. Highly recommend it. And if you don't know what a Git detached head is and you want to Google for it, just be aware. Okay, wrapping up. A couple more helpful scripts if you want to learn how to set up your own Nomad cluster. It's not trivial. It's not hard, but it's not trivial to like figure it out yourself. You can look right at the repo. There's a link right here in the slides and in the repo for setup SHA. And if you want to manage your own HTTPS certs, like on a domain level, there's a nice little script there to help you with that too. Okay, wrapping up, final slide. Kubernetes is the many-pound, 800-pound gorilla. Hashi Stack is smaller, lighter. It's a single binary for the entire tool, or for each tool. So there'll be like a 50 or 100 meg tool for Nomad, 100 meg tool for console, and then an Etsy script for your auto restarts. Real simple, real easy to remove, real easy to add. Kubernetes is used almost everywhere, so huge familiarity. Tons of people, whereas in the Hashi Stack is much lesser known, also ran. There's larger networking footprint with Kubernetes, which might get you into trouble or may not, depending. Hashi Stack is pretty minimal. If you're deploying to cloud, well, Kubernetes is great for that. It's a one shot and go. Whereas if you're deploying on premise, Hashi Stack's probably going to be a little simpler. I'm in a 15,000 DevOps Slack, pretty spicy and really interesting. And the general consensus there, and other people I've talked to, is that Kubernetes is great if you've got a team of 2 to 3 full-time DevOps for teams of 20, 50, 100. Whereas if you've got 50 or less or so, or maybe even more, probably one person part-time is going to work with the Hashi Stack. And just skipping the kind of redundant, if you want to use Kubernetes, it's got the role-based access control, which is superior to the access control list of Hashi Stack, but you may not need all that. So it's kind of up to you, and they've got namespaces abilities, or you can turn those optional. Thank you so much for joining my talk. I know it's a little long. That's not my cat, but the cat is adorable in the costume. So thank you for attending. The slides are at this bit.ly link. I'll give you a few seconds here. And the repo is at gitlab./internet archive. It's /nomad right after that. It's linked right here. Easy to find. Thank you so much for being here. Enjoy GitLab 2020. I'm sure it's going to be wonderful. I can't wait to see all the talks that everyone has to offer. And I will be continuing in the chat room that I've been in to answer any questions until people are done with questions or comments. So thanks again, and happy GitLab 2020.